Hi, this is Tom, and in this video we're going to look at what are called rational exponents. So before we begin, let's do a little reminder. Remember, a rational number. A, a rational number is a fraction. Or actually, it's any number that can be written as a fraction. That can be written as a fraction. For example, we so often, when we have something so simple like the number 2, we forget that the number, or let's try negative 2 even. Let's try negative 2. We forget that negative 2 is the same as negative 2 over positive 1. And if we write it that way, we just wrote we wrote negative 2 now as a fraction. And remember, it can also be written as 2 over negative 1. These are, in fact, all the same things. And we can even write it as, and some, like if you're writing a textbook, sometimes it looks nice just to put the negative way out in front. So the number negative 2 can be written in any of these four forms. But the key here is that negative 2 is a rational number because here we wrote it as a fraction. So today what we're going to do is we're going to look at rational exponents. So remember, so far we've been looking at something like, let me erase that. So far, we've been looking at whole number exponents, for example, 2 cubed. But now what we're going to do, and then we could multiply it out, is we're going to look at things like 5 raised to the 1/2. How could you write 5 raised to the 1/2? And I'm going to show you how. So the number in the numerator of the rational exponent is the exponent as you know it. The repeated multiplication. The number in the denominator is the index. And I'm picking a number like 5 to the 1/2 because this is actually a deceivingly simple example. And what we do is we can go from this form, the number raised to the fractional exponent, to the radical form. And remember what we said. We said the index goes right here. And so in this case, the index is 2. And then we write this as 5 to the first power. And you can also write this as square root of 5. And the exponent can also be outside the radical as well. And notice that when you're talking about a square root, that the 2 is implied. So if you don't see anything written, then there's a square root is what's implied. But if you're taking a cubed root or a fourth root or something greater than 2, then the index will always be written. Okay, let's just try a couple simple examples. So, for example, if I have something like the cubed, we're going to write it the other way, the cubed root of 5 squared. Well, if we look at our example up above, then this is 5. The exponent is the 2, and the index is the 3. And remember that we call 5 is called the base. So this is our base number here and here when we're talking about a number written as as written to some exponent, even if the exponent is a rational number. Now let's try another example and see how you can actually use these to calculate. So let's do this. Let's take the cubed root of 64. Well, if we write this in using radical notation, this is the same as 64 raised to the 1/3 power, because remember, there's always an implied 1 to the exponent for any number. Oops. Implied. Now, but let's see if we can do better. Notice that 64, well, 64 can also be 8 squared. It's also 2 to the 6 if we wanted. You might even remember that it's the same as 4 cubed. Raised to the 1/3. Now, when we have an integer or an exponent raised to an exponent, we multiply those. So this is really the same as 4 to the 3/3 power. But 3/3, well, that's just 1. So this is just 4 to the 1st power, and we would just simply write that this is 4. And so we can use our rational exponents even to simplify problems. Let's try one more example, and before we do this, I want to do a little reminder. And this is called scientific notation, but the idea is that it's used for large or small numbers, but let's just look at how it works. Notice if I have 2 times 10 squared, that's the same as 2 times 100, which is, and I'll write that, 2 times 100, which is 200, sorry, 200. Now, if I have something like 2 times 10 to the first, well, that's 2 times 10, which is 20. If I have 2 times 10 raised to the 0 power, well, this is just 2 times 1, which is equal to 2. Now look at what happens. Each time the exponent on the 10 decreases, then the numbers of zeros decreases as well. So when 10 is squared, there's 2 zeros. When 10 is to the 1st power, there's 1 zero. When 10 is to the 0 power, there's no zeros. Well, let's try this. What about 2 times 10 to the minus 1? Well, following our pattern, this would be 2 times, notice the decimal keeps moving, so this is 0.1 now, or this simplifies to 0.2. If we continue that, that's 2 times 10 to the minus 2. Well, that's 2 times 0.01, or 0.02. Now, you might say, well, I see the pattern, but where does that come from? Well, if you were to say, if I highlight these, let's take a look at, we're going to look at this 0.1 for a moment. If I was to ask you to correctly say 0.1, you would say, well, that's the same as 2 times 0.1 really is 1/10. And then you would recall that, wait a minute, 1/10 is the same as 2 times 10 to the negative 1. So you've been using negative exponents, but maybe just not realizing them. So, for example, in this next one where we have 100th, if I was to say that correctly, this is 2 times 100th. So, but that's the same as 2 times 1 over 10 squared, but that's the same as 2 times 10 over 1, which is this 10, or which is, I'll write that, that's 10 over 1, and then we use the negative 2. And the idea here is that, remember, the negative exponent flips the fraction. That takes a bit of practice, but let's try some. For example, if I asked you to do this, write 1 over the square root of 2 using rational exponents. Let's try this then. Let's try this. First, we'll start with 1 over the square root of 2. And we already looked at the square root. That's the same as 1 over, the whole exponent is 1/2, so 2 to the 1/2. Now wait a minute. I can even do this. You know, I'm gonna take a slightly different route here. Sorry for the change in thought, but I think this will make it clear. Let's do this. This is 1 over the square root of 2. And remember, you could just extend square root sign because the square root of 1 is just 1. Well, wait a minute. This is 1/2 raised to the 1/2 power. But I can flip the fraction by changing the sign on the exponent. So I could write this as 2 over 1 raised to the negative 1/2. But that's the same. But 2 over 1, that's much easier to just write 2 raised to the negative 1/2. And that's how you can use rational exponents even with negative numbers. We're going to stop there, and in the next video, we'll take a look at some more examples with more details. Thanks for watching.